these limits from a graph and from making tables of values. But it would be nice if we didn't have to do that all the time. Agreed? Isn't it kind of annoying to make a table and have to plug in 3 values smaller and 3 values larger? Or sometimes a graph, you can't always tell for sure. So we need other options, more efficient ways of finding these limits. And that's what the limit laws are. So we are going to run through this list. Let's just say that the limit as x approaches a of the functions f and g both exist. So neither one does not exist. They both are out there. Then the limit of the functions added together is just adding the individual limits. Okay, so if I said you have x plus 2 and 3x plus 1. You can either add those functions together and then find the limit, or you can do the limit of each one separately and add them together. Same thing, either way. That works with adding, subtracting, multiplying, limit number 4, dividing, as long as the bottom isn't 0. So all of those operations, you can break them apart and do the limit of each one separately. The third rule says if you have the limit of a constant times your function, you can pull the constant out. Do the limit of the function, then take that number. So if I had the limit of 3x, you could do the limit of x, get your answer, and then take it times 3. All right, so if I gave you these graphs and asked you to evaluate the limits using those limit laws. So the first one, limit as x approaches -2 of f of x plus 5g of x. So the limit law says we can do the limit of the first plus 5 times the limit of the second. We can break these apart. So as x approaches -2, you're here on the graph. F is this pink one. What's the value of that limit? You're approaching -2 from both directions, so the value of that limit is 1 plus.
When do we use the close O whenever it's like the exact?
Yes, if there's no limit there. 5 times the limit as x approaches -2 of g of x. So g is this blue one. When my x is -2, what's the value of my limit? 1. So I get 1 plus 5, which is 6 for this overall limit. So really, these limit laws are just giving us comfort that all of our normal rules of algebra still work. So if I have the limit of these things multiplied, I can do each one separately and then multiply my answers. So as x approaches 1, what's the limit of f?
I have a question.
Yeah.
On the G one, why isn't it -1?
It definitely is. Yeah. How about, that would make that a -4, wouldn't it? Thank you. See, it's just making sure you're paying attention. You passed for the day. All right, B, as x approaches 1. So x equals 1 is right here on my graph. What's the limit of f, the pink one? 2. What about g? It doesn't exist, does it? Because the left and right don't match up. So if one piece doesn't exist, the entire thing does not exist. All right, C. The limit as x approaches 2 of f divided by g. So at x equals 2, the limit of f is what do you want to call that? 1.5 over, what's the limit of g? 0. Can you divide by 0? So what do we get? Does not exist. So up until this point, if we were looking at the graphs, I just had you do one limit, but now I might be asking you to do several and some operation between those. All right. Let's go over, we're just going to look at the last few laws and then we'll probably stop. If you have a power, so if I have a limit of x squared, you can find the limit and then put your power on. So we could do the limit and then square that answer. The most useful rules are going to be 7 and 8 here. This is what's going to save us so much time. Rule number 7, the limit as x approaches a of c equals c. I said the limit as x approaches 3 of 1. Okay? If my function is just 1, that is a horizontal line. So no matter what value you're approaching on there, you're still on that horizontal line, and it's just 1. So the limit of a constant is that constant, always. Number 8, the limit as x approaches a of x equals a. So if I said the limit as x approaches 2 of x, my answer is just 2. So I am telling you here that if it's just a plain x, you can just plug in the number you're approaching. Okay, the reason that works is if you think about x, y equals x, that's the identity. So your points on it are 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So that's why that works. Number 9 is telling us if we have the limit of x to a power, we can just plug in. So if I said the limit as x approaches 3 of x to the 4th, I don't have to make a table of values. I can just plug that in. It's going to be 3 to the 4th, which is 81. So these are giving us shortcuts for how to evaluate our limits without actually making that table or drawing a graph. Last two, you can, same thing works for under a radical. So if I said the cube root of x, you can just bring that 3 in. And if you have a function under your radical, you can bring the limit under the radical. So tomorrow we are going to start working examples with all these. I just want to kind of touch on what these rules were.